Hello. Hello, Internet. How the devil are you? Let me just move some stuff around here a sec. I'm so prepared for this. There we go. I can see what's going on down there now. Hello, my name's Hoffman, and I do music and a bit of coding. And a bit of background, I guess, in terms of stuff. This weekend, we were all supposed to be meeting up for a little gathering called Mini Nova, which is kind of like it was going to be our sister party to our main demo party, Nova. Um, and for those of you watching on catch up a year or two later, it's 2020. So you know what that means. Which means we didn't get to catch up with everyone. So instead, we decided to do a bunch of stuff online, some streams, watch some demos together, and generally bring ourselves together via the gift of all this amazing technology that we have, which is exactly what we're doing now. So my name's Hoffman, or Ian. I'm currently drinking Old Speckled Hen, because that's pretty much all you can get whilst everyone's panic buying all the good beer. So we are streaming on Twitch via my channel and via UK Demo Scene. So if you're watching on my stream today, DJ Hoffman on Twitch, then go over to UK Demo Scene and go and check us out there, because there'll be stuff going on, and you know what else you got to do? You're locked in your house, aren't you? So yeah. Shout outs to everyone. We'll do that in a bit. So I guess a bit more background. Today we're going to be talking about my Amiga Synth engine system thing that helps me make sounds for Pro Tracker modules, which means that you can squeeze them into a really small space. But it means you need some pre-calc time. Now, if you don't know what an Amiga is, Google that now. Simple enough. If you don't know what the demo scene is, Google that as well. If you don't know what Pro Tracker is, Google that. I'd probably give you a bit more background on that, but let's be honest, if you're watching this, then you probably know what I'm talking about anyway. Shout out to those in the old chat room there. See, now this is, it even happens on my radio show, this Hemo Stick, I can say that. Hello, Art State Digital, big ups, Fox, Hapt1X, Wister Tube, and everyone else in there. Yeah, and Spiny, big ups to you, and of course Rory, everyone else on UK Demo Scene Slack. Let's just move some stuff around here so I can see what's going on. Yes, we can see everything. Right, so my synth engine and what it does. On the right here, this thing here, that is Pro Tracker. This is a music piece of software where basically you can load in samples. So let's have a look here. Here is a sample. Oh, it's rather large, that. Let's cut it down. You should be able to hear that. Let me just double check my sound settings to make sure you can hear that. Yes, fabulous. So you can load in a sample. And play the EastEnders theme with a zap snare type thing. And you can play 4 samples at the same time. So you can have samples here. So lovely. And you can have samples over here. So yeah, that's how Pro Tracker works. Let's just clear that now, because we don't want that clear all. There we go. It's a piece of software from 1993. Wow, I'm old. Why would you make a synth engine for a computer that's 34 years old? Because you can. Why not? I do a lot of DSP stuff. I really enjoy it, so why not give it a shot? Slightly more technical side. The Amiga has got a Motorola 68000 processor that runs at around 7 megahertz. That's kind of a 16-bit processor, so it's quite hard to do some chunky maths on it, and it's quite hard to do stuff quickly. So the principle of this synth engine is that almost everything that we do is calculated or rendered effectively in a pre-calc phase, so before you start playing music. So you have to generate your samples via this code. It fills up the memory, and then you can start playing them. So let's move ourselves off of there. So we know what Pro Tracker is. We know what an Amiga is. So this window here is what I call my whoops. Forgot that did that in Windows. Do not shake your windows. I've lost every single window now. Bear with me, callers, whilst I just pull all of these back up, and I'll try not to do that again. And we need the Twitch window, and we're back where we are. It's a quick. Perhaps there is an Amiga Sound emulator that runs in JS. I'm sure there is. I'm sure there is. Yeah, good old Aero Shake. Yeah. Anyway, so onto this, which is what I call my project editor. So it's split up into 4 sections. So here are my instruments, which I tell what we'll do is, before we go on to these other bits, because this is a brand new empty project that I've got here, we'll just dig into the synth engine and effectively how that works first. So these are instruments. So if I create a new instrument, here's my instrument window. I can say this is a new instrument. Oh, I did shrink that down. New sound. Okay. And there's my new sound. Okay. So let's go and edit an instrument. Let's make an instrument. So the basic premise, let's just clear this out. So this list here in this big white box that we've got here, this is where effectively your stack of devices go. Now, the way the synth engine works is that it will have effectively a buffer or a certain amount of sound that it has, and then each device that you create for this synth engine effectively reads and replaces that buffer. So it's effectively, the best analogy, I guess, is like an insert chain in a modern door. So an insert chain, you'll have a signal that comes in, and with that signal you can put an effect on it which will read that signal and then push out either a mix of that signal and the affected sound, or replace it, or whatever. So each device basically runs in that principle. So the best way to demonstrate this is to, let's just say, so we've got a set of devices here. So hopefully you can read those all okay. So I'm going to add a noise, voice noise, which I'm sure you're going to guess what this does. So if I hit my render button, lovely, white noise. Okay, so that's just white noise. And this device here that I've got here will basically fill the buffer with white noise. And I can set the volume of that white noise . And there you go, job done. Release it, perfect. So yeah, so that's my first device. So this is effectively a chain of devices, or a stack, I guess you could call them. Each device doesn't know what the other one's doing. The only thing it can really do is affect or use the signal or the sample data of the previous one. So in our most basic of DSP / audio synthesis engines, we obviously need an envelope. And I still haven't fixed that, which is really annoying. Obviously these devices, I can move them up and down as well. So obviously having an envelope before a noise generator is going to do nothing. So you obviously want that afterwards. So an envelope has all of the kind of parameters you would expect for an envelope. So it'll have an attack, a decay, a sustain, and a release. I've got a couple of extra hi Rainbow Chaser. A couple of extra functions in my envelope, because within a DAW or a synth engine or MIDI even, you have a note on and a note off, which would then determine how long it's going to play that note for, and then when the decay would start. Obviously, I don't have that in my engine, because you can't send it notes. It's just going to generate a sound. So I developed these things here called attack hold and sustain hold, which then basically says when it gets to the top of the attack, it will hold that value for X amount of time and then decay, and then when it hits the sustain level, it will hold that for X amount of time and then perform the release. It means you can really play with how that envelope actually reacts. So let's just do a basic one, a nice quick decay. Let's actually turn up our noise again, and then we've got, yes, lovely. Let's push that decay up. Lovely. Oh, the sound is amazing. And then we can put our sustain level on there. Let's put a release on there as well. And then obviously we can change our attack. Oh, it's like the seaside, isn't it? Lovely. So that's our noise. That's our envelope. So let's just say, for example, then, so let's just go through some of the additional devices we've got here. Let's clear our noise. And the only other one I've got, one of the other ones I've got here is called Voice Twin, which we'll add that. We'll remove our envelope. So this is, it's just a twin oscillator, effectively, with a set of waveforms that you can pick from. These waveforms are stolen from a program called Music Line Editor, because they're all 256 bytes long, which makes for a reason in assembly language as to why that's handy, because it's to the power of 2. So the twin voice that we've got here, we can select a waveform for each of the oscillators, what volume it is, and we can also set a note that it would play. Let's just do something a bit higher. Let's do a nice C3, and we've also got fine tune pitch on here. So if I render this like this, lovely, good old down ramp, or I guess that's a sawtooth, isn't it? So you can instantly get a drum and bass line if we just pitch down that one, pitch up that one, and then render that. So they're slightly detuned. Nice. That's lovely. So as I was saying, in terms of it being a stack system, so we could then put an envelope on the end of that. Let's move that down. Let's put a little bit of attack, a little bit of decay. Let's get rid of that so it peters off a bit quicker. So there we go, and we can obviously change that to be quick. There we go. So another little device we've got here is called delay, which is exactly as you would expect it. It is a delay unit. So we've got an amount of signal that we send to the delay, feedback level, and a length in samples at the moment. This isn't the most useful, but let's really whack this up. There we go. Maybe a bit less on that. It feeds back forever. Might actually be a bug, that. We can obviously change that so it's longer, or really tight so it sounds really metallic. Oh, nasty. Okay, let's get rid of that delay because the delay is never very good. Let's pull that down a bit. Okay, better. Okay, so going through the other items that we have here, a basic gain, which is quite handy here because we can make it quieter or louder. You can actually get this distort stuff and really hard clip stuff as well, which is quite handy. But that's pretty basic. Let's have a look here. I won't go through the gain LFO because that's an experiment that has not worked. I will delete that piece of code because it's rubbish. Voice noise, an envelope. I'll go through Synth in a minute because that's a special case. But the big thing, particularly for me, was to make sure I could get a filter to run on an Amiga 500, and a good one at that. So if any of you do DSP stuff, you'll probably know what a biquad filter is. It's a filter algorithm that's really quite good and very flexible, but it's quite heavy on the computation. Actually, if Daniel Collin is there, he helped me incredibly convert this floating point math stuff that's inside the biquad into integer maths, and we managed to get it working on the 68,000 CPU, and with a bit of chugging away and optimization, got it running so that you didn't have to wait 30 seconds for it to filter an entire sample. Yes, that's right, Stewface 79. The target platform will be the Amiga 500 and up. But I'll get on to why that's complicated. But in terms of CPU, that's right. That is exactly where it would run. So a biquad filter, I've currently got this one configured to do low pass, high pass, and band pass. The low and high pass work pretty well. The band pass is a bit weak, to be honest, but let's just demonstrate what that does. And of course, we've got our Q setting here as well. Oof. Which is pretty cool. You hear those little little bits of artifacts that we end up at the end of our sounds. There it is. Lovely. Yeah, you just have to kind of cut that stuff off, really. Big ups to THMS DJ who's just joined us. Yeah, it was about 7 megahertz, the 500 processor. Plus, you got chip RAM. So, there you go. Okay, let's do the high pass, which is, again, pretty good. So, a pretty handy synth. Maya, nice to see you there. So it's pretty versatile, this filter. The band pass is unfortunately a little bit quiet. So that's probably where your gain would come in. I need to look at that. I think there might be something wrong with the calculations within that band pass, but that's for another day. So the other thing we have here in terms of the toolkit and our devices is we can have a biquad envelope, which is super useful. So this is a biquad filter with an envelope built in. So this is where stuff really starts to get quite fun. So as you can see here, we've got a frequency, a Q, again, like you would with the filter. And we've got an envelope amount that can either go positive or negative. So the way the envelope works is it starts at this point, and if you say the amount's going to go up by that much, it will then do an envelope upwards and then downwards and then back to that point. Again, if you did it in a negative, it would go that way and then back that way. So we can probably, if we're really lucky, get a little bit of 303 action maybe. Let's have a look. Oh, why did I set those up there as default? Oh, lovely. We can obviously sort of play with that decay. We'll make it proper wowie. Or pull up that resonance. Or take it down. So actually you can totally break this because of the computational limits within inside the A500's 68,000 processor. And oh, it's not doing it today. Let's try it on the high pass. That always breaks it. It's behaving itself very much today. What on earth is going on? Hang on. Okay, you can see here on some of the previews here that we are kind of... You see these artifacts that get left over. These are because of again, that computational limitation that we've got within the Amiga. But it doesn't matter when you get to these points. These things sound a bit, you know, dirty, but I kind of like that. So okay, so I tell you what we'll do then. So let's call that our DAW. Okay, lovely. Okay, and there's my sound now, my DAW. Okay, we're just going to drop back into there one more time, into the instrument editor. And I'm going to explain the last piece of kit that's in my tool belt here, which is Synth. Now let me just clear everything here. So Synth is an entire synth engine in one device. Now, if you know Blueberry, good friend of mine, I hope you're doing well, mate. He made a synth engine for the Amiga 500 that can run in 4 kilobytes of space. I mean, in terms of the samples it generates, they're quite big, but you can fit it into a 4K production, and it's really good. It's effectively it's basically a kind of weird FM based synth, FM synthesis. If you're not sure what that is, I don't either, and I've been using it for years. So let me just show you what this can do in terms of a synth. Okay, not very much, just a sine wave at the moment, as you can see. But effectively the synth runs with 2 oscillators. You have a main oscillator and a modulation oscillator. So the modulation oscillator will modulate the other oscillator. So just to give you an idea of kind of what that sounds like, I'm going to push up this modulation. Okay, that's quite long, isn't it? And a little bit loud, so I apologise if that is too loud for you. Yeah, just think the 1980s DX7, except without a ton of operators. Oh, hi Colextra, how you doing? So Typecode Amiga was still pre-render, no pre-rendered samples on PC for Pro Tracker. No pre-rendered samples on PC for Pro Tracker. We'll get on to that in a minute, ArtState, in terms of how that actually works. So at the moment, let's finish on Synth first anyway. So it's an FM synth engine. So let's just demonstrate what on earth that can do. Let's push this B pitch up to there, and then you'll start getting... Ooh. That's pretty nasty. Let's push our pitches up a bit. This is quite a tricky synth to use, if I'm honest. But with a bit of perseverance, it is a lovely bit of kit. So this will probably... bear with me a moment. I'm just going to sort out my... Yeah, let's turn that down just a touch. Yeah, there we go. That's better. Lovely. Lovely. So we can put a decay on that modulation, and then we'll have probably quite a nice little effect. There we go. We're starting to sound like a 1990s arcade machine or a Mega Drive now, aren't we? Lovely. This has decay built in. Lovely. And it's also got distortion for the modulator. so it really breaks stuff. Nice. And final distortion there as well. Lovely. So that is an entire synth engine that I plugged in because the code's open source. So I added an entire synth as a device in this. But then what that gives us is a unique and lovely situation. So, okay, so I've now generated my sound with Synth. Just because it's really loud and distorted, I'm just going to add myself a gain here. So we can just pull that down a bit. Brilliant. And then on top of that, I can now put my biquad envelope filter. And let's wow that up, shall we? Oh, bit more. Turn it up to 11. Oh, yeah, there we go. We broke it at last. How about that? Finally broke it. Let's see, turn that down a bit. Oh, that is nice, isn't it? And then let's we could add some noise to that as well, which is going to make this sound terrible. Oh, actually, that's not too bad, is it? It's not as bad. As you've probably guessed, with most of the stuff that I do in terms of sound design, it is experiment until you get a happy accident. Okay, let's really... Oh, it sounds menacing down there, doesn't it? Spooky. Obviously, we've got our high pass for that as well, so... Ooh. Let's try that. Lovely. So you can see already we're oh, let's just chuck a delay on top of that as well, shall we? Move down. Yeah. Let's put a lot of that in. Bit of that, and then is Adlib the Sound Blaster? I think it was. Hey, Alkama! I'm sending you virtual hugs because I can't see you for bloody ages. I send virtual hugs to everyone actually at this difficult time. Oh, Doc Retroid, lovely to see you there. Okay, so I think that pretty much does it in terms of our synth engine. So this is an instrument. I can stack these up as many ways as I like. So if I wanted, let's just clear that. Let's just say we want a chord. Just add a voice twin. This is quite easy to do. So we'll just do a nice happy major chord. So I've got a C and an E. Okay, copy that. And then we'll go for a G. And why not go just above that to the next C. Do you know what? I really hate the major chord. Hang on, this is more me. Yeah, lovely. So quite easy to chuck a chord together, and we can obviously add these oscillators up to make a massive padded chord. So that's just some of the sound design stuff that we can do with this. Now, I guess the real question is, how do we actually use that? So I've been hitting this render button the whole time, showing you kind of how it sounds and what it does and what we can do with it. But there's a lot of stuff that goes on under that render button. So under that render button, it's the execution completed in however many million cycles. It's not an accurate reading for those that know what they're talking about in terms of CPU cycles, but I've wanted a status. So what this effectively does is when I hit that button, it exports all of this parameter information, all of these devices, all of the parameter information, what the values are, throws it into a tiny little binary file, puts that onto disk. And then using Python to execute a C-based 68000 emulator, it then runs a version of the synth engine, which is an instrument render. So it's a little Amiga executable that will take that file and then render the audio So that is already a sample. In fact, we can go to it, but I'll show you in a slightly more sad chord. Let's call that sad chord. Okay, lovely. So the good thing about that in terms of using the 68,000 emulator means that in terms of the code I'm writing for the synth engine that operates within the Amiga, I know that when I run that, that is the actual code that's being run, so the output will be exactly the same. So when I come to actually drop it onto an Amiga, I know everything's going to be correct. So it's a real bonus for me. I like it like that. That's very good. Let's see, there are a bunch of Yamaha keyboards. Yes, there were. My PC friends had sound blasters. They're all talking about sound blasters and FM chips in there now. I've lost them. Anyway, so let's get on to the subject of actually writing some music, shall we? Because there's no point having a synth engine if you can't write some music. So this is quite easily done. So in our instruments section, we can edit an instrument, create a new instrument, we can copy an instrument, we can delete one, we can save it out to disk so that we can load it into a different project, or we can load an instrument from another project from disk into here, and we can export all of the instruments as samples, so we can load them into ProTracker, or we can just pick one of them and go, okay, I'll export one. Now what this will do is export an entire 64 kilobytes of sample data, which is why I've now got an export one button, because when you've got 30 odd instruments in here, which you'll see later, it takes a bit of time. Okay, so we've now exported that, which means if we go back to ProTracker, which is here, in my folder, which I've got everything set up lovely, we should see now we've got sad chord. Lovely. Okay, and let's say I load that up and I go, actually, I don't like that. I want that. Let's go and quickly change that, shall we? So we'll go, okay, now I want it to be the happy chord. And in actual fact, what I want is I want a high passed enveloped happy chord. So let's go high pass, blah, blah, blah. Let's put some attack and decay, some sustain. See what that sounds like. Rubbish. Let's change that like that. So we could just, in fact, let's just make that shorter. Okay, I'm happy with that. So that's that done. I can now export that again. In actual fact, in this version, because I'm running it in via an emulator, it'll just load that. You see there's all 64K of it. Don't need any of that. Let's get rid of that. And let's just do something really silly. Instant. Lovely. That's what we like. If we could do that with any of the instruments that we've got there. So which one was this? This was our... Yeah, that's our DAW. Okay. So let's export that. Okay, so we've got our chord. Yep, and we've got our... what was it called? Oh, did I actually hit the button? I didn't hit the button on it. So I've got to select the sound, then export one. Lovely. And now, here it is. Now you'll notice here that all the sounds that I'm exporting have got an underscore at the front of them. And that's because of what we're going to probably talk about next, which is, okay, I'm loading a sample into ProTracker. In terms of when I split all that up and try and build that real time on the, well, not real time, when I pre-render that stuff on the Amiga, how do I know what to put where? And obviously that's a process that you want that's nice and simple, and you can just press a button. Lovely. Oh, you can really hear that. Ooh, it's nice, that, isn't it? So yeah, we can now actually effectively, let's go. No. Ooh, there we go. Okay, there we go. Should we get all Romeo Knight on this? Okay. Okay, we'll get on to the serious business of how this works in a minute. Here we go. We've got insects crawling through leafy undergrowth. I like that. Okay, so let's. Sorry if I've been missing. If you've got any questions, just put them in big capital letters on the chat. I'm not very good at keeping track of that kind of stuff. Okay, so here is my now rubbish tune. Okay, so this is obviously a project editor. So I can set a BPM. So I know my BPM here is 125 BPM because we need that. And our project name is rubbish tune, obviously. And now I can save this as a project. I'll call that project rubbish. And now I've got all of my instruments saved in their original format. I can go in there, I can edit them. So now comes the interesting part here. So I can now load my tune in, if I can find it, mod.rubbishtune. And now you'll see these are all the sounds, all the samples that are in that tune. And you can see, because this one's got an underscore at the start of it, because we save all of our samples with an underscore, it recognizes that that's an instrument. I'm not going to hit the export button because I think it might break in this particular scenario. In fact, why don't we just see what happens? Unhandled exception, of course. Yeah, thought that would happen. Let's... As you can see, I've got my code still running here because this is all very much work in progress. Let's reload our project. Rubbish. Okay, so I load my tune back in. Rubbish gen. No. Oh, hang on. What did I do there? Yeah. How portable is 68,000 code to other platforms of the same CPU? Bossman, that's a great question. The answer is massively. If it's a 68,000 processor, this will work on any of them pretty much, I think. I don't think there's any reason why that would be an issue. But yes, you could run this on an Atari ST and render samples with it. There's no reason why you couldn't. To be fair, you could have done that with Blueberry Synth. You can do it with this. Anything that's generating code, generating sample data, it shouldn't really be leaning into the hardware because it's just doing calculations to generate numbers, and that's it. So yeah, it's totally portable for your Atari ST if you wanted to use it there. Rubbish gen. Okay, load module. That's why. Rubbish tune. So as I was saying here, you can see it recognizes that. The other thing the project editor also understands is, let's just say we load a sample, just any old sample. Okay, let's load another one, might as well. We've got a kick here somewhere. Clap, that'll do. So yeah, we got our samples in there now, and now you'll see when we load this up now, our tune, let's reload it in. No, not the rev tune, the rubbish tune. You'll see it's recognized that these two things here are just straight samples. So when it comes to exporting the project so that the code knows how to re-render everything, I'll show you in a minute. No signal input. Massive spoilers coming. There, yeah, we will. Might as well. Okay, yep. I was just getting a sideline bit of information there. So, lol. There we go. I just realised just what the time is. Blimey. Let's try and get through this a bit quicker then, shall we? So, samples. So it'll recognise those. In terms of compression for those, we've got a few options here. The P61 Delta doesn't work at the moment, but the Delta and the Double Delta do. That is lossless. That is ever so slightly lossy, but it really does save on space when you start packing this stuff together. So this recognizes instruments and samples, but there's an entire other section that we're now going to go into, which is the drum system. And I realize I spent so much time on this already that we're going to be running out of time. But anyway, let's go for some drums, shall we? As you may have heard from Eon, we use a technique there where basically we would deconstruct a 4-channel module of drums into a loop, into a flat loop. Well, we would take a Pro Tracker module with drums that runs as 4 channels. We take all the samples out of it, we'd take all the pattern information out of it, and then we'd store just that, because then that's a lot smaller. We're only using individual drums, and then we could render those drum loops on the fly whilst the demo was running, saving memory and loads of disk space. All of that tech is built into this as it already stands, so it's already part of the system. So basically, the principle is you write your tune in one module, and then you do your drum loops in another module, which means you've effectively got 7 channels, which is great. So here's an example, which you're going to get massive spoilers now, so you're going to hear stuff that's going to be for revision, but I haven't got anything else as an example at the moment. Let's just play this pattern here. Okay, so you can see it's 16 lines long, uses 4 channels a fair amount of the time. Oh, it's a bit choppy changey. So what you can do with that, bumpy. Yes, very bumpy. All right, Vamps, how you doing? So we can load that drum module into here. There's the drums. So this is all the samples. These are all the samples within that drum module, and these are all the patterns. So what we can do with that is we can actually play that pattern, but it sounds wrong because we've got the sample rate for the drum loop generator at the wrong rate. Lovely. Then we've got another pattern there. Oh, I didn't actually. There's only actually 2 patterns in my tune at the minute. So what that is effectively doing is rendering that as a single sample. So let's say, for example, we want to export all of those drum loops. Let's just clear this, clear all, lovely. And exports those as drums 001, 002, 003, depending on which. There's some other crap in my folder which I haven't deleted. So you can see each drum loop would have taken us about 30 odd kilobytes each. So we've got 3 of them. So we've used well over 90 kilobytes of sample data already. But in actual fact, because we're only using those individual drums and then pattern data to render these, we're using hardly anything at all. And there it is. Lovely. There's another one. So one little feature that I added this week that I just really wanted to show off because I'm super proud of this bit. You'll notice here, so if you've used ProTracker before, you know there's a sample offset command, number 9. And that works in intervals. So the value that you can put in is a number from 0 to 255 or 0 to FF if you work it in hex. And that can only run an offset of 256 bytes at a time, or 100 bytes in hex. So when you generate a drum loop, trying to reach the exact point on your transient or your additional points that you want in your sample is incredibly hard to do. As you can see here, we've got the command here called 8. Now the 8 command in ProTracker does nothing. It's a spare command. No one ever used it apart from for doing synchronization and stuff. So when this drum loop generator over here recognizes this command on this line, it effectively sees how many bytes it is to the next position of 256 and fills it with a blank so that you can then export. You can jump to those particular positions precisely, which is really helpful. So I can demonstrate if that probably makes sense, but it means we can do, I'll just show you here. Oh no, we've loaded it now. Okay, turn that down. No. So yeah, that's one drum loop that we got here. You'll see actually just before this transient, you might see it. You see that little gap there where there's no sound? That's so that when I put the number, where is it? I forget, this doesn't use page up and page down. And okay, entered the machine code monitor. So there at 22, that is effectively that position right there, exactly to the letter. Now, if this, so this is a good example here. So if the sample had started there, but then I jumped there, I would have missed all of that kick drum. So that's why that is really helpful. Okay, so that's pretty much all of that. So your drum loops, you can export them to a sample and then you can load them back into your module. So let's demonstrate that by loading the Rev 2020 generator project. Ooh. Oh. Whoa. Okay. What happened there? Please hold, callers. That is not right. Please hold. Just getting into my Google Drive moment. Go to Google Drive. Yes. Why is that? Okay. I think this might be doing. I think I might have a bug in my code. Hopefully. This is slightly embarrassing, isn't it? Talk amongst yourselves for a minute. That'll help. Please say I've killed all my work. Aha! Yes, can we have some manage versions? Thank you. Friday. Download. That's looking better. Right. Whoops. Okay, regularly scheduled programming will return right now. There we go. Project. Replace the 295. Okay, with that. Replace with that. Ah, there we go. Right. Ooh, that's better. Oh, that was a bit. Okay. Good to have backups. That's right. That's exactly right. Yes, mate. Have backups. Yeah. Brilliant. We're there. Okay. So, just to demonstrate slightly further in this, you will now see that this tune we've got here, Rev Tune 01. Okay, which has got drums, some samples. As you can see, the underscore, an instrument there. So drum loop. Yep. More sound, more instruments. You can see that. Lots of instruments in this. And then a sample. Then another sample. More instruments. More instruments. How wasteful on an Amiga to use an instrument on 2 different samples for 2 different octaves. It's really, I know. Classic. So yeah, a lot of instruments there. So as you can see from our setup here, it's recognised that that's a drum loop, that's a sample, that's an instrument. Okay, so it recognises all of that. We've got our drum loops in here that we could listen to. We've got a whole stack of sounds that we've created here. New chord, so we can just go like that. Yeah, end of that. Check that out. So that's that chord stab we had there. And then we've got obviously the super mega magic export button. And that's done. It's exported. So we can now have a look at this, which a lot of you may know what it is. It's Visual Studio Code, obviously. Start demo, yeah. So that now generates all of the tune data that we need. Let's go and pull that together. Yep. So we've got a project config, tells us how much RAM we're using, tells us tells the code what sample mode we're using in terms of compression, project information. So here we go. This is our generator project data. All in source for some reason. Didn't generate a data blob. I don't know why. Probably so I could see this stuff here. So this is a list of tune instruments. So it's an instrument type. So let's see, that's an instrument there. That's a drum loop. So the code knows what to do when it reaches each of these. The size in words, so not bytes. And then a pointer to where that data is, if it's a sample or a drum loop or whatever. These are the sample pointers for the drum loop system. So again, just a list of samples, removes any ones that we haven't actually used. What is that one? And then our instrument data, as you can see here, is just a collection of numbers, and that's it. So it spits that out, and then the synth engine underneath reads that information and regenerates the sound for us. These are are drum loop patterns that have got these positions in that I was talking about earlier. Actually tells us the exact hexadecimal position that I need to use when I'm back in ProTracker, which is quite handy for those. And samples.i, that's just a list of samples that we've got. And then you build all that. And then build your project. Actually, we got the demo running, because then we'll at least get a... so this is... we're nearly to the end now, so I hope you've enjoyed this. I'm now going to spoil 2 minutes of revision soundtrack, so you can hear it now. But then maybe I'll just upload this onto YouTube in a few weeks. So you'd seen it, but no one else is going to see it. So until afterwards. Maybe that's a good idea. So yes, trying to work on a demo. Got some bits and this soundtrack. So this uses all of that stuff that we've built, and you'll now see it. Let's just check that it actually builds, because this is always fun. Yes, it's built. What's your name on YouTube? It's I don't know actually. Don't know. I'm not releasing the synth at revision. No way. No. It's not yet. There's a lot of code work to do that. I guess I should field any questions before I do this. Yeah, I'm not going to release the synth at revision because as you've seen there, I hit 2 unhandled exceptions. So the code is very much reliant on you knowing where the data is supposed to be and everything's supposed to be. Oh yeah, we're definitely releasing the demo at revision. Oh yeah, demo's happening. So I mean, I've been working on this since December. I'm not going to stop now. So be a shame to waste that lovely revision logo that Far wrote as well. So yeah, I should know it's my channel. It might be Ian Ford on YouTube. That'd be quite embarrassing, wouldn't it? I should probably change that. So anyway, you're going to now see a progress bar, which is probably the most exciting thing I ever coded as part of this, and it did crash and write all over memory at one point. So you'll see that, and that is basically, that is the... there was one thing I forgot to mention about the double buffered drum loops to save on RAM, but you don't really need to know that. It's just a technical detail. Means you save on RAM. I have infinite drum loops almost, but anyway, I'm now going to run. So that's all built now. So that data comes out of there, comes into here, and then this can build it and render all the samples before it starts playing the music, and then it can start playing the music. And you're going to see that now. Takes a little while. Guess it's worth mentioning this is very work in progress and very rough around the edges. It's not subtle how it does this bit yet. Lovely ending there. I still haven't fixed that bug. Not sure why that goes back to the Amiga DOS window with that weird color palette. That's really odd. Anyway, that's it from me. I hope you've enjoyed this. I guess at some point this will be wrapped up and we'll have some more interesting devices in there, and we'll give it out to everyone to make tunes with, and then harass me for support because it doesn't work. Because that's how it works with open source projects, doesn't it? So thanks to everyone in the chat room. There's been loads of you chatting. Thanks for coming along and listening to me ramble on. Just another reminder, let me see if I can get some link action in that window for you, because let's be honest, what are we doing today? Not a great deal, apart from sitting around and just hanging out, innit? Let's see. No, how did I manage to completely mess that up? There we go. Can I post links? Am I allowed to? Oh, no. There we go. Meta. Meta. Oh, no. There we go. Meta. Meta. Yeah, we don't want that. That's bad. So I posted that link into the channel for you. We are having a little stream day today. I will be probably DJing on UK Demo Scene org and stuff a bit later. I've got some stuff to do at the moment, so I've got to chip off. I've got a delay unit here. I have, yeah. So yes. Keep on the UK Demo Scene Slack Twitch channel. We're going to be watching demos. We're going to be doing stuff, showing stuff, more stuff. Let's keep together. Stay safe, everyone. Much love, and I shall see you when I do another stream. All right. Love you all. Bye.